Welcome back to Biology from Jay's house. Today this is going to be a circulatory system review video. So there's going to be no new information. This is just a moment for me to take all the concepts that we have covered and put them all together into one video to prepare you for the quiz. So let's start at the basics. Why do we even have a circulatory system? And the answer is we have a circulatory system because we need three things. And we don't just need them, but every single cell in our body, from our toes to our nose, needs air, specifically oxygen, water, and nutrients. And we have to get those everywhere. Otherwise, cells would be on their own. We'd have to get all this stuff. We'd have, like, our knees would have to breathe, and our elbows would have to eat, and our, toes would have to drink. But instead, what we decided is, hey, we'll have the organism handle all this, and then we will deliver them. So we will have a postman that goes to every single cell in your body, and he will bring some nutrients to you. He will bring oxygen to you. He will bring water to you. And then you don't have to worry about acquiring it. The organism, the entire organism, will take care of acquiring it, and this postman, simply called blood, will bring it to you, and then cells can just pick up nutrients, water, and air from the blood whenever they need it. So that is the purpose of the circulatory system, to bring these three things to all the cells in your body. Okay, and well, how does it do that? Well, you got this thing in the middle of your chest. It's called a heart. That's about the size of a heart, slightly smaller, about the same size as like your fist. So if you take your fist and look at it, that's about the size of a heart. And it has 4 bits to it. It has 2 upper bits. That's where blood comes in. So these are the receiving bits. And then it has 2 lower bits. That's where blood goes out. And it doesn't swap between the sides, which means if it comes into the right atrium and goes down to the right ventricle and then shoots out, the only way it gets back here is actually by leaving the heart, going somewhere, coming back in, and then it'll come back in these pulmonary veins, go down the left ventricle, and then head out through the aorta. But it never swaps between these, and it can't. And the reason why is because this half, you can see it's kind of a little bit blue. That blue implies that it is low on oxygen. And the blood on this side of the heart is low on oxygen. And the blood on this side of the heart is rich in oxygen. And I wonder why. Maybe because it's swung by the lungs? So what happens is it comes in here, goes out, shoots out to the lungs, picks up oxygen, then it comes back in, goes out and shoots out to the rest of the body, drops everything off, then comes back oxygen poor, shoots off to the lungs, and comes in oxygen rich and shoots out to the rest of the body. So let's see a quick diagram of that. There you go. That's what the human heart looks like. This side is oxygen poor, this side is oxygen rich, which means it leaves whoosh, whoosh, through a thing called, well, if it's going away, that better be called an artery. And we remember that because away and artery both start with A's. And if it's oxygen poor, then I know where it better be going. It better be going to your lungs, where it can pick up delicious oxygen. But it's going way too fast in the artery to do that. So what it has to do is it has to slow down. And it slows down by going and branching off and becoming smaller and smaller and smaller branches. So it'll branch here, and then it'll branch here, and then it'll branch again. And each of these tiny little branches, where these are so small that red blood cells actually go through single file, these tiny little branches are called capillaries. And this is where blood goes slow enough. So arteries are like highways and roads, right? And capillaries are like parking lots. That's where blood goes slow enough that it can actually stop and actually pick up some of that delicious oxygen. Thank you. Right? Because that's why we have lungs. We have lungs because they breathe in the oxygen from the air and they put it right by the blood. And that's the purpose of that. I think we'll learn about that system very soon. And now it's full of oxygen. So it goes back in. And thank you, Casio, for pointing out that vein has the word in. So if it goes back into the heart, then it is a vein. And now it has tons of oxygen. And all it does back in the heart is pick up more power, pick up more speed so that it can make the long journey out to every part of your body. Your elbows, your knees, your everything. In this case, we're just going to say toes because I have a convenient printout that I did of toes. And again, this is going away. So it's an artery again. Away artery. And this, again, going way too fast to actually drop anything off. There's no way that the toes would be able to pick up the water, the nutrients, or the oxygen in the blood. So we have to get smaller and smaller. So we do on this end also, you would have these capillaries. So the blood goes through all these little capillaries. Oops, I drew that wrong. Shh, don't tell anyone. Luckily, no one's actually watching these videos, so it's fine. What? Oh, I actually drew it wrong. Like, drew it all the way wrong. There we go. And it goes back in. And these also are capillaries, because capillaries are everywhere where the tubes are super small. And they're small enough that blood can go slowly or even stop without causing a problem. So those are the parking lots again, and that's where it will drop off all the stuff. And since one of the things it drops off is oxygen, then it will return oxygen poor. And again, it'll go back in to the heart vein. Goes back into the heart, and around it goes. So if we now take our little postman, hello, and the postman has a bunch of water and a bunch of nutrients that it picks up from our digestive system that we haven't learned about, so we're just going to say it has it. And it gets some power, and it says, hey, I'm really low on oxygen. It swings by the lungs and picks up some oxygen. Sweet. And it's only in the capillaries that it goes slow enough to do that. And then zoom, it flies through the vein. Poosh, gets pumped through the artery, and then it slows down again, and the toes go, hey, I could use some water, and I'll take some nutrients. You got some oxygen for me? Yeah, no problem. And then it speeds up through the vein again. Boosh, gets pumped through the artery because of the heart, and swings by the lungs, goes very slowly through the capillaries, picks up some oxygen, and then whoosh, whoosh, it flies through the veins, through the arteries, through the highways and roads. And here it goes slow enough. It says, hey, now that I'm going slowly in the capillaries, I can drop off stuff for you. There you go, toes. And then whoosh, whoosh. It flies through the veins and arteries, goes slowly through the capillaries, slowly enough to pick up more oxygen. Whoosh, whoosh. Then it goes slowly enough in the capillaries again to drop off all the deliciousness. Whoosh, whoosh. And around it goes, constantly either picking up stuff in the capillaries, whoosh, whoosh, or dropping off stuff in the capillaries, whoosh, whoosh. Forever and ever and ever, never stops. So, arteries and veins are like highways and roads. Blood is going very, very quickly. I should write that up here too. Veins are also highways and roads. It's an ampersand, not an 8. Arteries and veins are highways and roads. They're both going super, super fast. It's only the capillaries that are parking lots. You go slow when you pick stuff up, and you go slow when you drop stuff off. Okay, that looks good. Now, let's get on to, well, let's talk about this blood stuff. Blood, which is usually just red stuff, actually comes in 4 parts. If you take the red stuff and you spin it around super fast, so that's what they do, is they take a vial of blood, they put it in a thing called a centrifuge, and they just spin it super fast, and the heavy stuff goes to the bottom, and the lighter stuff goes to the top, and it ends up looking like this. This is normal blood, like if you got a cut. The same stuff that comes out of your body looks like this if you spin it enough and push all the heavy stuff to the bottom. And what is that stuff? Well, there it is. You have your erythrocytes at the bottom. Wait, what's that? You have your Buffy coat, huh? And you have your plasma. Oh wait, I've heard of plasma. So this is how people refer to it in industry. We are going to talk about the 4 different parts, and we're going to go from bottom to top to middle. Bottom, at the bottom, is simply red blood cells. That's 45% of your blood is red blood cells. And what do? They carry air. That's all they do. They just carry air. And then the top, the liquid portion, is all the water and all the nutrients. So if I look at blood, it only looks like there's kind of 2 bits. There's the red bit, which carries air, oxygen, and then there's the kind of yellow stuff called plasma, which carries the water and nutrients. That's kind of all of it. And the answer is that is basically all of it. That's 99% of blood. Almost 100% of blood is just those 2 bits. But if you look really closely, you'll see in the middle, it's not a straight line. There's a little bit right in the middle bits. And those middle bits are made up of 2 things. That's the platelets, which are right in that tiny little section between the red and the yellow, right there. The platelets and the white blood cells. They make up less than 1% of your blood, which means most of your blood either carries oxygen or carries water or nutrients. And what they do is the platelets patch holes. If you get a cut, the reason that it heals and blood stops squirting out of your wound is because of platelets. They get sticky near gaseous air, which is where the holes are, and they patch up the holes. And the reason that you're not sick all the time is white blood cells. There are germs out there attacking you all day, every day, but they rarely win because your white blood cells fight them off. Woohoo! And that's less than 1% of your blood patches holes and fights disease. Most of it just either 55% carries water and nutrients all over your cells, or carries oxygen all over your cells. Okay? And thinking about the red blood cells, so if I leave this up, and the red bits, again, are the red blood cells, and that yellow bits are the plasma, and we're not going to talk anymore about the platelets and white blood cells, though we know they're in there. I want to talk about blood type. And your blood type affects your red blood cells and it affects the plasma in your body. So depending on the type of blood you have, we're just going to look at the red blood cells right now, which are the parts that carry the oxygen. If you have type A blood, then there's these things called antigens. And the antigens, which are shown here as little circles, they're not actually circles on your red blood cells. So this red bit is a single red blood cell, and the little circles around it are the antigens. If you have type A antigens, which are really chemicals, they're not cute little spheres. If you have type A antigens on your red blood cells, then you have type A blood. If you have type B, which are the pointy ones, but they're not, again, actually pointy, they're just a different chemical. If you have type B antigens on your red blood cells, then you have type B blood. And what if you have both? What if you have the round bits and the pointy bits? Well, instead of getting creative, scientists said, let's just call it AB, because you've got A and you've got B. Look at that. We'll just call it AB blood. And what if you have bald red blood cells? Well, since these are letters, we should probably call it a letter. Is there any letter that looks like 0? Oh yeah, there's O. Okay, we'll call it O. That way, everything's a letter. So if your red blood cells have the A antigens, you have type A blood. If your red blood cells have the B antigen, you have type B blood. If they have both, you have AB blood. And if you're bald, you have O or 0 blood. As in, we chose O because it looks like 0. That's the red blood cell part. Now, what about the plasma part? Your blood type also affects the liquid in your blood, because floating in there are going to be chemicals that check to make sure that your blood is your blood, not somebody else's blood. So they come in 3 flavors. Anti-B turns off type B blood. Anti-A turns off type A blood. Anti-A and anti-B, if you have both of them, then you can turn off type A blood and type B blood. And there's a type that, well, has no antigens. I mean, antibodies. Sorry, these are called antibodies. So, antibodies live in the plasma, as in the liquid portion of your blood, and they come in only 2 flavors. Anti-B, which turns off type B blood, anti-A, which turns off type A blood, or you have both, which is anti-A and anti-B antibodies. So coming back, and let's fold the antigens into this. That means let's actually pick up your red blood cells and take a look. If you have on your red blood cells that carry air, if you have the chemical type A antigen, then you have type A blood. If on your red blood cells you have the type B chemical, then you have type B blood. If you have both the A and the B chemicals, then if you have type A antigens and type B antigens on your red blood cells, then you have AB blood. And if you have no antigens, you're type O. And now you get this cute little grid. Whoosh, whoosh, whoosh. If you have type A blood, turns out that in your plasma you also have anti-B antibodies. And that's fine because this only turns off type B blood, but you have type A blood. So it works out perfectly. If you have type B antigens on your red blood cells, in your plasma, in the liquid portion, you have anti-A antibodies, which turn off type A blood but don't do anything to B. So these don't interact, and that's fine. If you have type AB blood, well, you can't have anti-A antibodies because they would click on to the A part, the A antigen in AB blood, and turn it off. So you can't have anti-A. And you can't have anti-B for the same reason. It would click on to the B antigens on AB blood, turn it off, and it wouldn't work. So if you have AB blood, there are no antibodies in your plasma. None. There can't be. And if you have type O blood, you get them both because there are no antigens to turn off. So anti-A can't turn this off. Anti-B can't turn this off. So you're good to go. Now, it doesn't matter at all what your blood type is. At all. You can go your entire life without knowing your blood type, with having to worry about your blood type. It only matters when you receive blood. That is the only time your blood type matters. You can donate all the blood you want. That's fine. It is the receiving part when somebody else tries to give you blood, that this matters. So we're going to look at, let's do type A blood. So let's say that I have gotten a big, huge cut. Oh no. And I have lost a lot of my type A blood. Oh gosh. Look at all of it. Well, in type A blood, I would also have anti-B antibodies in there, right? My red blood cells have the A antigen, but the plasma part of my blood also has the anti-B. And this isn't all my blood. This is floating around in all my blood. Well, what happens if somebody tries to give me blood? Well, when we donate blood, we donate just the red blood cells. So if someone tries to give me type A red blood cells, well, that works out just fine because the anti-B can't do anything. Click, click, click. I can't turn it off. So if I'm type A blood, I can receive type A blood. And as you might guess, it doesn't matter what blood type you are, you can receive the same blood type, no matter what. But what if somebody gives me type B blood? Uh-oh. Now my anti-B antigen, or antibodies will click onto the type B antigens and will turn this off. And, oh man, the blood doesn't work. So you've just filled my body with useless blood. Thanks. Well, what if I try to receive AB blood? Again, I get the AB blood, the anti-B antibodies that are in my blood, click onto it and turn it off. Oh, thanks. You've just given me useless blood. But what about O? I put O in. Hey, you're bald. I can't attack to you at all. And that's why O can donate to anyone. If you have type O blood, you can give to absolutely anyone because your blood can't be turned off. So it doesn't matter what antibodies are in the blood, you can donate to them. And that's why they're called the universal donor. So the only time the blood type matters is when you're receiving. What blood can go into your body, right? And what really defines it is not the red blood cells that you have. It's actually the plasma portion of your blood. The plasma portion, the part that's the water in the liquid, has these antibodies in it, and that's going to decide whether the blood coming in works with you or doesn't. So to look at this one more time, now let's quickly look at what if you have AB blood? Well, if you have AB blood, what antibodies do you have? Well, none. Wait, if you don't have any antibodies, and you can't, right? If you had anti-A antibodies, it would turn it off, so can't have that. If you had anti-B antibodies, it would turn it off, so you can't have that. So anyone with AB blood can't have any antibodies. And what that means is you can receive from A, because there's no antibodies to turn off. You can receive from B, because there's no antibodies to turn it off. You can receive from AB, because there's no antibodies to turn it off. And you can receive from O, well, because O can't be turned off. So AB is actually the universal receiver. Just kind of a neat thing. So there we go. That's the circulatory system review video. We talked about the purpose of the circulatory system, which is the circulatory system in the most basic sense is nothing more than a mailman who brings delicious oxygen, nutrients, and water to all the cells in your body using the heart, which is a dumb pump, arteries and veins, which just move blood really quickly, and capillaries where blood goes slow enough to drop stuff off and pick stuff up. Blood has 4 bits: red blood cells to carry oxygen, plasma to carry the water and the nutrients, platelets which patch holes, and white blood cells that fight disease, and all of those are in your blood. And your blood type is defined by the antigens on your red blood cells, but it also ends up defining what antibodies are in your plasma, and it only comes into play when you receive blood. Good luck on the upcoming quiz. Adios.